So here I have come with another new episode on current electricity. So if you still not subscribe my channel, then subscribe it and click on the bell icon so that you can get the updation, okay, of the new videos. So my name of my channel is Physics Scholar. So today some very important topic I will discuss. So in the previous episode, if you can follow, I have discussed about the resistances, the combination of resistances, the cell, how the cell, what is the condition to get the maximum current from the cell, what should be the combination. So that type of theoretical portions we have completed. Now in this section today we will learn the power of electrical circuit. What is the power of electrical circuit? So what we know in general definition, the rate of doing a work is known as power. So if the work done is W and time is T, then power will be W by T. So electrical circuit, in case of the electrical circuit, it will take some electrical energy, it will consume electrical energies, the electrical appliances connected in electrical circuit. So what is power of electrical circuit? So electrical energy electrical energy consumed in unit time. So that is known as electrical energy consumed in unit time, or electrical work done per unit time is known as power of electrical energy. Okay. So suppose the work done is equal to W and time taken is T. So power P is equal to W by T. Okay. So that is the power P is equal to W by T. So hope you have understood what is electrical power. So electrical energy consumed per in unit time is known as electrical power. So suppose the electrical work done is W and the time is T. So the power P is equal to W by T. So the unit of power is basically watt, and in case of the commercial purpose it is used as kilowatt. So basically 1 kilowatt is equal to 1000 watt. So very basic relationship between the kilowatt and watt. So the power unit of power is watt and the bigger unit is kilowatt. Kilowatt is used for commercial purposes. Okay, the electric energy meter, how much it is used in kilowatt unit. The power, how much energy consumed, that is used. Okay. So hope you can see this now. Okay. So 1 kilowatt is equal to 1000 watt. Power P is equal to W by T. So this is the power. Now some basic formulas are there which is used to solve the numeric problems. So what are the formulas? What we know? Power P is equal to W by T. Now W is equal to what? V into I into T, where V is equal to what? Potential difference. I is equal to flow of current through the electrical circuit, and T is equal to time. So that is the value of W. Now we are putting this in this equation 1. So P is equal to V into I into T by T. T will be cancelled. So P is equal to, therefore what? P is equal to V into I. So power is equal to what? Voltage into flow of current. Now what we know? V is equal to I into R from Ohm's law. R is the resistance of the circuit. Okay. V is equal to I into R from Ohm's law. I is equal to flow of current. R is equal to resistance of the circuit. So now what we know? P is equal to V into I. So we are putting the value of V here. So I into R into I. Therefore it is what? I square R. So power P is equal to I square R. Again, what we know? V is equal to I into R. Okay, V is equal to, and power P is equal to V into I. So what is the value of I from Ohm's law? V is equal to I into R. So I is equal to what? V by R. Okay. So now we are putting the value of I in this equation. So what will come? What will come? P is equal to V into V by R is equal to V square by R. Okay. So how many equations we are getting in terms of power? Power P is equal to V into I. This is we have done. Again, power P is equal to I square into R. This we have done. Okay. Again, power P is equal to V square by R. Okay. We have done here. Okay. So three equations of power. Power P is equal to V into I, P is equal to I square into R, P is equal to V square by R. Depending upon the data provided in the numeric problems, we have to use these formulas, okay, to determine the power of any electrical circuit. Power P is equal to V into I, P is equal to I square into R, P is equal to V square by R. So these are the formulas of power of electrical circuit. Okay. So this is how we can derive it. Now there is a relationship between the kilowatt hour and joule. Between the kilowatt hour and joule. So 1 kilowatt hour is equal to 1 watt is equal to 1000 watt into 3600 second. So 3.6 into 10 to the power 6 joule. So 1 kilowatt hour is equal to 3.6 into 10 to the power 6 joule. Okay. If the work so 1 kilowatt, what that is the relationship between kilowatt hour and joule. 1 kilowatt hour is equal to 3.6 into 10 to the power 6 joule. Clear? Now let us what we know? Power P is equal to V into I. Okay, that we know. So now multiplying both sides with T. What do we know? P into T is equal to V into I into T. Okay. So now what is the value of V? V is equal to I into R. Okay. So V is equal to I into R. Now you can put here P into T. That means energy consumed. Okay. Total energy consumed is equal to what? V means I into R into T into I. So it is I square RT. So that is the electrical energy consumed. Electrical energy consumed in time T. Okay. H is equal to what? I square RT. Okay. So this energy actually, will convert it into the heat energy ultimately. Okay. So H is equal to what? I square RT. So this is actually the Joule's law, and we will come to know about the heating effect of electric current. Now this is the energy consumed by the electrical appliances. Okay. So if any electric current flows through any electrical instruments, then what will happen? Then the heat will be generated. Okay. So that this is known as the heating effect of electric current. Why the heat will be generated? What is the reason behind it? What we know, that through a conductor the free electrons are there. Okay. So when the flow of electricity will be there, then there will be a flow of free electrons. But in the materials, the other electrons are also there. So the free electrons will collide with the other electrons. Free electrons will collide with the other electrons of the that is there inside that materials. So during this collision, what will happen? actually the resistance of the materials will develop. Okay, it will oppose the free electrons to move very freely. So resistance will be there. So during this collision, what will happen? The energy will be converted into heat energy. That's why the heat will be developed when there is a collision between the free electrons and the other electrons which are there in the materials during the flow of current. That is why the heat is generated. So if the resistance increases, then heat will also increase. Now how much energy is generated? That is derived from the Joule's law. Okay, so that is derived from the Joule's law. How much energy is there in the, so if we actually, what we know, H is equal to I square RT. That formula already we derived. How it has come? So suppose H is the amount of heat, I is the flow of current, R is the resistance of the circuit, and T is the total time taken. Okay, means total time during the flow of electric current. No, so suppose now the heat, number one, three laws are there for these three conditions. Okay, heat, energy develops is directly proportional to the flow of electric current. Okay, when R and T are constant. That means that is the first law. What? H is proportional to I square when R and T are constant. Okay, so that means what? Heat energy develops is directly proportional to the flow of electric current when R and T are constant. Clear? So H is various I square. Secondly, what is the second? Second is H is proportional to R when I and T are constant. Okay, that means what? If flow of electric current and time is constant, then the heat develops is directly proportional to the resistance of the conductor. If resistance increases, then heat will also increase. That's why the electric heater or electric iron what happened? Actually the conductor, the wire we are using, the resistance is very high. So when the current will flow through it, then what will happen? It will generate a huge amount of heat. That heat we can utilize, okay, in case of the electric heater or electric iron. So hope you understand this. Okay, so this is the reason. Okay, next one is what? H is proportional to T when I and R are constant. Okay, that means if flow of electric current and the resistance is constant for any conductor, then heat generated is directly proportional to the time, how much duration the electric current is flowing through that conductor. If electric current is flowing for a long period of time, more amount of heat will be generated. If it is flowing to a less amount of time, then less amount of heat will be generated. So this is actually this is known as the Joule's law. Okay, so this three is known as Joule's law. How we can derive how much from Joule's law we can derive how much amount of heat energy is generating when the flow of electric current is there. So hope you understand this, the Joule's law. Now we will start some numeric problems. Okay, so students, now whatever the formula I have shown up to this, so we will do some very simple numeric sum which are very important for the exams in your school or board. And the concept needs to be clear. This type of, so we will solve 4 or 5 sums by using different type of formulas. So this is a very simple sum which uses more energy, a 250 watt TV set in 1 hour, a 1200 watt toaster in 10 minutes. That means the power is given here 250 watt TV set. Okay, so the power of TV set P1 is equal to what? 250 watt. So we are converting into kilowatt is equal to 0.25 kilowatt. We are dividing it by 1000. Okay. So time is given. Time T1 is equal to 1 hour. So energy consumed H1 is equal to what? P into T. So P means what? 250 into T means 0.25. 0.25 into 1 kilowatt hour. So 0.25 kilowatt hour. So this is the energy consumed by the TV if it is run for 1 hour and the power is 250 watt. So 0.25 kilowatt hour will be the energy consumed by the television set after running 1 hour. Now we have to find out toaster, how much in for the same way. Okay. So the power of toaster is given what? P2 is equal to 1200 watt. We have to convert into kilowatt, 1.2 kilowatt. Okay. So time taken, time T2 for how many time? 10 minutes. 10 minutes. So we have to convert it into hour. So 10 by 60 is equal to 1 by 6 hour. Therefore what? Energy consumed H2 is equal to P2 into T2. What is P2? 1.2 into 1.6 kilowatt hour. So it will be 0.2. So 0.20 kilowatt hour. So which one is greater? H1 is equal to 0.25, H2 is equal to 0.20. So H1 is greater H2. That means H1 means power consumed by television. So TV will use more energy. So very simple but important sum. So TV will use more energy. Very simple. Which uses more energy? A 250 watt TV set in 1 hour or 1200 watt toaster in 10 minutes. So the power of the TV set P1, we are converting the watt into kilowatt. Time is given. So you can write it P1 T1. Okay. So energy consumed H1 is equal to P1 T1. So P1 is 0.25 into T1 means 1. The power of toaster P2 is equal to 1200 watt is equal to 1.2 kilowatt. Time taken 10 minutes. We are converting minutes into hour. Then 1 by 6 hour. So energy consumed H2 is equal to P2 into T2. So 0.20 kilowatt hour. So energy consumed for television will be greater. H1 will be greater than H2. So TV set will use the more energy. So this is the sum. So hope you understand this. So let us move to the next sum. So students, here another very simple numeric sum. This type of sum is very common. So calculate the monthly bill of a heater of resistance 40 ohm which is used on 220 volt mains such that it is used daily for 5 hours. The total cost of energy is given. That means that is the unit charge per unit electric charge per month. Okay. So now we have to do the things. So calculate the monthly bill of the heater. So resistance R is equal to 40 ohms. Okay. Now which is used? So voltage V is equal to 220 volt. Such that so power P is equal to V square by R. What? We know that. Just in this episode I have shown. So V square means 220 into 220 divided by 40. So this will be cancelled. 11. Okay. Okay. What? is equal to 1.210 kilowatt. 1.210 kilowatt. So that is the power. So energy consumed. Energy consumed per day. Per day. H1 is equal to 5 hours we are using. So 1.210 into 5 kilowatt hour is equal to kilowatt hour. So energy consumed per month. Per month means we will assume 30 days. So 6.050 into 30. Kilowatt hour. So total cost, it is the per unit charge, it is total energy consumed. So 1.50 into 3.60 is equal to rupees. So 181.50 181.50 and 36, just multiplication. So it will be 653.40. So that will be your answer. So very easy. So I am explaining, resistance R is given 40 ohms, voltage V is equal to 220 volt, power P is equal to V square by R. That formula you know. Watt. So we are 1210 watt. So we are converting into kilowatt, 1.210 kilowatt. So per day we are using for 5 hours. So per day energy consumed 1.210 into 5. So this is coming. So per month means 30 days. So it will be multiplied by 30. So this is kilowatt hour. This is the total energy consumed. So total cost will be total energy into the amount. So that will be the electric bill. So if sometimes the questions come like this, multiple devices are there which are using for 1 hour, some other devices are used for 2 hours, some are used for 5 hours, whatever. So in that cases, all the devices total power consumed we have to find out, and then we have to add, and then we have to multiply with the electric bill per unit. Then we will find out the total electric bill. So that type of sum also very often comes in the examination. So let us move to the next numeric problem. Okay. Now this is another very common type of numeric problems. Okay, students. So several electric bulbs designed to be used on a 220 volt electric supply line are rated 10 watt. How many bulbs can be connected in parallel across two wires of 220 volt? That means the voltage of the line in parallel connection, the voltage across each bulb will be same, and the minimum allowable current is 5 ampere. Okay. So what is given? The voltage V is equal to 220 volt. Power P is equal to 10 watt. So what we know, rate resistance is equal to R. So what we can write? P is equal to V square by R. Therefore R is equal to V square by P. What is V? 220 into 220 by P means 10. Therefore R is equal to 4840 ohms. Okay. Now let n number of bulbs can be connected. So current drawn I is equal to what? 5 ampere. So R effective is equal to what do we know? V is equal to I into R. So R is equal to V by I. So what is V? 220 divided by I means 5. (44 ohms). So what will be the equivalent resistance? N by R, reciprocal 1 by R plus 1 by R plus 1 by R. So n number of bulbs, so it will be N by R is equal to what? 1 by R reference. Equivalent resistance, reciprocal equivalent resistance is equal to sum of the reciprocal of all the resistances. So here resistances means the bulb. So n number of bulbs. So total 1 by R plus 1 by R plus 1 by R plus dot 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 plus up to n term. That means what? N by R. And this is the equivalent resistance. So therefore n by what is the value of R? 4840 is equal to 1 by 44. Therefore n is equal to 4840 by 44. Therefore n is equal to 110. So how many bulbs we can connect? 110 number of bulbs we can connect in this circuit. Clear? So I am explaining once again. So voltage V is equal to 220 volt. Power P is equal to 10 watt. So let the resistance R. So P is equal to V square by R. This formula I have shown. So R is equal to V square by P. So V square means 220 into 220, that is the voltage of the circuit, and power P is given as 10. So the resistance of the circuit will be 4840 ohms. Now let n number of bulbs can be connected. So I is equal to 5 ampere. So effective resistance of the circuit will be V by I, 220 by 5 is equal to 44 ohms. Now let us assume n number of bulbs are connected. Then what will be the equivalent resistance? All are connected in parallel. So it will be what? 1 by R plus 1 by R plus 1 by R plus dot dot up to n. So that means what? N by R is equal to what? Reciprocal of the equivalent resistance. That means 1 by R effective. Okay. So n by what is the value of R? 4840 is equal to 1 by R effective is 44. So we are finding the value of n is 110. So 110 number of bulbs can be connected in parallel in this particular condition. Okay. So it's a very easy sum, but very common and very effective one. So you see this. So hope you can now do this sum. So let us move next. So here see, compare the power used in 2 ohm resistors in each of the following circuit. So first and second, two conditions are given. 6 volt battery in series with 1 ohm and 2 ohm resistors. Okay, so let us consider the first one. So voltage V is equal to 6 volt. So these two resistances are in series, 1 ohm and 2 ohms. So that means what? Equivalent resistance is equal to 1 plus 2, series is equal to 3 ohms. Okay. So flow of current I is equal to what we know? V is equal to I into R. So I is equal to V by R. So what is the value of V? 6 by 3. That means 2 ampere. Flow of current will be same in case of a series circuit. So power of 2 ohm resistor P1 is equal to I square R I means what? Flow of current. 2 square into R means what? 2. 4 into 2, that means 8 watt. Next one, number B. It is number A. Now number B. What? A 4 volt battery. So here voltage is equal to 4 volt. So power P2 is equal to what we know? V square by R. So R means 2. So V will be same as they are connected in parallel. So it will be 4 into 4 by 2. That means 8 watt. So that means what? Compare the power used. So in both the cases power used by 2 ohm resistor will be same. That means 8 watt. So I am now explaining it once again. Voltage V is equal to 6 volt given. So in case of the series, the same current will flow. Okay. So now equivalent resistance will be 1 plus 2 is equal to 3. Flow of current I is equal to V by R. So we are finding the flow of current. That will be same for each resistances. That there are those who are connected in series. So power P1 is equal to I square R. This is the another formula. I have shown this. So I means 2. So 2 square into 2 means 8. Now voltage is equal to 4 volt. Now in case of the parallel circuit, the voltage of across each of the resistances will be same. The voltage across this and this will be same. So V square by R. So 8 watt. So in both the cases it is also 8 watt. For 2 ohm resistor it is also 8 watt. The power across 2 ohm resistor. Okay. So in both the cases the power will be same. Here it is connected in series, here it is connected in parallel. Now you see this. So I hope you can understand and you can copy also if you want, and you can understand this. Now so many numeric sums are there. Also the combination of resistances we have done. So complicated circuit we will solve. Slowly we will move to the harder problems. So many complicated problems are also there which are very important for board exam as well as for the IIT joint. Now another part, that is electric fuse. So that I will discuss here. What is electric fuse? Electric fuse is a safety device. Nowadays in place of fuse we are using MCB, miniature circuit breaker. Okay. So the function of MCB, the internal structure of MCB, that I will discuss in details in another episode. So what is fuse? Fuse is basically a safety device which is one porcelain board is there and a wire is there. Okay, the wire is connected over there. So this is known as the fuse wire. Fuse wire. Always remember, in electrical circuit, two paths should be there. One path the current will enter, another path the current should come out. So two paths will be there. If one path is not there, then that circuit will be open. So no existence of current will be there. So this path, the path through which the current is entering in an electrical circuit, it is known as live wire. Live wire. And the path through which the current is coming out from the circuit, it is known as neutral wire. It is known as neutral wire. Okay. So the path through which the current is entering in a circuit, it is known as the live wire. It is live wire and this is neutral wire. So live wire is the entry path of the current in a circuit and neutral wire is the existing path of the current from a circuit. Okay. Now the fuse. So what is the fuse? Fuse wire has a rating. So if the current flows beyond that rating, then what will happen? The heating effect of current. The fuse wire is the wire which have a low melting point. A low melting point. A fuse wire is a wire which has a very low melting point. It has a rating. So if more amount of current flows through this wire, then what will happen? This wire, the heat will be generated and this wire will melt. This wire will melt and no current can enter in the circuit. So that is how we can save our electrical devices from from overflow of electric current due to any fault. Due to any fault means short circuit or any other fault may occur. So due to any fault, if the overflows of electric currents are there, then due to the heating effect of electric current, the fuse wire will melt and we can save our electrical devices. Now the fuse wire always needs to be connected in with live wire. How the fuse wire will be connected? So suppose this is the electrical circuit. This is the electrical circuit, okay, and okay. So the fuse, this is the fuse wire. It is always connected with the live wire. It is what? It is live wire, and it is neutral wire. Now this is the fuse. Why the fuse is connected with the live wire always? So I am giving one example. Suppose there is a security check. There is a house. So this is one gate and this is another gate. This is the entry gate and it is the exit gate. So one security person is available. So suppose the security person is there as in the exit gate. So what will happen? So any terrorist or any bad person can easily enter and do all the damage. He or she can be caught when he tries to exit from this gate. Then only he or she can be caught. But if instead of this, the security person is standing here, then what will happen? He can check whether the person is authorized or not. And if any ill person is there, then he or she can be caught over here only. So this is the things. If the fuse is not connected over here, if it is connected in the existing path with the neutral wire, then what will happen? Due to any fault, the extra amount of current will come in the circuit. But when it will try to come out from the circuit, then this wire will melt and the circuit will become open. But before it melt, the current will enter and do all the damage. So with all the damage of the electrical component that are connected in the circuit. So when it is coming out, then the fuse wire will melt and the circuit will become open. But before that, the damage already done. So that is why the fuse wire is connected with the live wire. Why? Because when the extra amount of current tries to flow due to any fault, then this wire will melt and make the circuit open. So this device which is connected over here, this will be safe. This and other instruments which are connected, that will be safe. So remember always that the fuse wire is always fuse or MCB. The function of fuse and MCB are almost same. So these are always connected with the live wire. It never can be connected, should be connected with neutral wire. Okay, it should not be connected in the neutral wire, it should be connected with the live wire. So this is the fuse. So I hope what is fuse and how the fuse wire is connected. So this concept you have understood. So in my next episode, I will come with some harder numeric problems on the different type of electrical circuit and the power consumed by the circuit and the equivalent resistance flow of current through the different branches, the problems on galvanometer, ammeter, shunt, okay, and then we will move to the Kirchhoff's law. Okay. So, I think you all have understood today's episode. So, thank you very much for watching.